Alright, here we're going to be talking about the distance and midpoint formulas. So the distance formula is used to find the distance between 2 points. Just like in the slope formula from last year, we label those 2 points as x1, y1, x2, y2, just to say that we have 2 arbitrary points with x and y values. I like this picture here because it actually shows you that. And the distance is the length between those two. To find that distance, we're going to take the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, I'm going to look at this picture. x2 minus x1 is basically just figuring out how far it is from left to right from one point to the next, that horizontal distance from one to the other, and then y2 minus y1 is finding that vertical distance from one to the other. So we subtract the x's, we subtract the y's, we square them, add them together, and then do the square root of that number. Alright, so we're going to find the length of this line segment, which is basically saying find the distance from one point to the next. So I'm going to label my 2 points. This one looks like that's at -5, +3. This is at -2, -3. So I'm going to substitute into that equation. x2, I'm just going to call this my x2 and y2. So I'm going to say -2 minus -5 squared plus y2 minus y1, -3 minus 3 squared. So that equals 3 inside the parentheses here, squared, plus -6 inside the parentheses there, squared. 3 squared is 9, 6 squared is 36, so this turns into the square root of 45. We cannot leave a square root like that. There's going to be times where we can leave our answers as decimals, but a lot of the time we're going to simplify this as a radical. So I want to think about how to simplify the square root of 45. So last year, I think your teachers taught you to find the perfect squares that divide this evenly. So I see that 9 would divide that evenly. That's a perfect square. And 9 times 5 is what gives you 45. You take the square root of the perfect square, leaving you with a whole number on the outside, and whatever's left over stays on the inside of the square root. So that leaves us with 3 times the square root of 5. If you're not certain about that process, you can always just check, figure out that as a decimal, figure out this as a decimal, and make sure you got the same decimal. Alright, what's the distance between A and B? The order actually doesn't matter here. It actually really is important that we label our x1 and y1 very carefully here. As long as you're subtracting the two values, it doesn't make a difference. So I'm going to subtract -3 minus 9. That's -12 squared. And 4 minus -8, that's +12, also squared. So in this one, I actually did use this as my x2 and y2 in both cases. But really, those can flip-flop. As long as you're subtracting the x's and subtracting the y's, it's going to be the same. 12 squared is 144, so is -12 squared. So we have 144 plus 144, or 288. Now, I know 144 is a perfect square, and I know that I just added them together. I added 2 of them together to get that. So 144 times 2 would give me 288. Square root of 144 is 12. 2 is the only thing left inside the square root symbol. So it's 12 times the square root of 2. All right, on number 3, we're looking for the length of the diameter. So we're trying to find the distance across this circle. I'm going to use the point that they're giving us. From there, stretching across to the other side of the circle, and I'm going to draw my diameter from there to there. Alright, so, oops. Alright, so we're trying to find the distance between these 2 points. From there, that's at -7, -1, to this point, which is -1, 7. So it's the square root of these two subtracted from each other. -7 minus -1 is -6 squared, plus -1 minus 7 is -8 squared. That is 36 plus 64, or 100. And so the diameter there, or the distance between those 2 points, is 10. An easier way to find that is just using more strategic points. From there to there also represents the diameter. We could just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The diameter is 10. If you wanted to, I guess you could have found the distance between the center and that point. That would have given us 5. That's the radius, and you could double that. All right, the last one for distance. What type of triangle is pictured? Scalene, isosceles, equilateral. Equilateral means all the sides would be the same length. Isosceles would mean 2 are the same length, and scalene would mean they're all different. So we have to find the distance between each of these pairs of points. I'm going to actually jump to the bottom here because there is an easier way for us to think about this. So the distance formula using x2 minus x1, that is basically just thinking about how far is that distance, that horizontal distance. Or thinking about the side length of a triangle. So we can sketch a triangle on each of these pictures and kind of just count how far are we moving left and right, how far are we moving up and down, and then use those as the two values that we're going to square. That's exactly what Pythagorean theorem does. We use a squared plus b squared to find c squared, or the length of that line segment, the distance between those 2 points. So on every one of these problems, we could draw a triangle, and we could end up just counting the side length. We could see this going across is 6, this going up and down is 8, 6 squared plus 8 squared. We add those together, we take the square root of that number, that's our final answer. This is a much easier way for me to think about it, at least. If you want to, you can find the x1, y1, find the x2, y2, and systematically plug into this equation. I just think it's easier for me to just draw a picture and count from D to F. I'm going up 1, 2, 3, 4. So when I do y2 minus y1, that distance is 4. So for DF, the x1 minus x2, or x2 minus x1, is just a distance of 1. We're going 1 to the right. So we do 1 squared. The difference in the y's is 4. So we do 4 squared. So df is 1 squared plus 4 squared, or 17. And really, it's going to be the square root of 17. I don't even care what that decimal is. I'm going to look to see if those other ones are going to be the same radical expression there. So I'm going from D to E. My horizontal distance is 1, 2, 3, 4. So that's going to be 4 squared. Again, if you wanted to do x2 minus x1, you'd end up doing 5 minus 1, which would give you that 4 anyway. I just think if you're going to be given a picture, you might as well draw the triangle and just count rather than subtract the coordinates. And then our difference in y's is just 1. We're going up 1 spot. So you can see immediately those are going to be the same. DE is also going to be the square root of 17. And then looking at that last one, FE, going from there to there. Horizontal distance is 1, 2, 3. Vertical distance is also 3. So that's going to be 3 squared plus 3 squared, which equals 18. So that is not the same as those two. So that side is a different length from those other two, so we have an isosceles triangle there. All right, so hopefully you understand the connection between Pythagorean theorem and the distance formula. Instead of subtracting the coordinates, this is just giving us a triangle in which those lengths represent the difference in the coordinates. You're also going to see another formula on your formula sheet, which is the exact same thing. The center of a circle is written as h comma k. So that's right there. That's just labeling the coordinates of that center. Any point on this circle can be represented as the x and the y in this equation. So when I say x minus h, I'm saying the x value of some point on this circle. So here, that would be 0, 4. So that would be the point 0 minus the x coordinate at the center, which would be -4 squared, plus the y coordinate at any point. It really works for any point on the circle. I'm just picking that one. Here I'm using 4 minus the y value at that spot is 1 equals the radius squared. Here the radius is 1, 2, 3, 4, 5. But you can see that this is measuring the exact same thing. The difference in two x values, the difference in two y values, equals the distance between those 2 points, the radius of that circle. These three equations are mathematically identical. These two and the distance formula. The distance formula is the only one that's not on your formula sheet. So you need to memorize it, but you actually have two formulas that are exactly the same. All right, you should be able to try these on your own. I'm going to talk about the midpoint formula, and that is it for this unit. So the midpoint formula finds the midpoint between 2 points, labeling them the same way, x1, y1, x2, y2. Midpoint, I'm going to call A, B. It's going to give us an x and a y coordinate, and the way we find that, we add the two x values together and divide by 2. And we add the two y values together, and we divide by 2. You're finding the average of the x coordinates and finding the average of the y coordinates. You're finding the point that's directly in between. So we're going to find the midpoint of these 2 points. We're going to find x1 plus x2 divided by 2, and y1 plus y2 divided by 2. That would give us -2 divided by 2 is -1. That would give us +4 divided by 2 is 2. That's our midpoint. All right, if a segment has endpoints of A and B, they're not telling us the endpoint, and the segment's midpoint is 15, -4, what's the location of B? So now we know the midpoint, we don't know one of the endpoints. So I'm going to say M is 15, -4, and we know we have to add these together, so it's going to be 1 plus x, we don't know that value yet, divided by 2, equals 2 plus y divided by 2. So we're looking to basically solve these two equations. This equation, 1 plus x equals 1 plus x divided by 2 equals 15, and 2 plus y divided by 2 equals -4. So we'd multiply the 2 over in both cases. We get 1 plus x equals 30, and subtract the 1 from both sides, and find out that x is 29. Sorry if I'm not showing enough work there. We multiply the 2 over and then subtract 1. Here we multiply the 2 over, we'd get -8, minus 2 would give us -10. So B is 29, -10. I do want to point out what I think is an easier way to do that. So you could set up these equations, but I'm kind of just visualizing what's happening there, going from A to B with my midpoint, 15, -4. Again, if you want to do it in a systematic way, set up these equations. I just think this is faster. So going from 1 to 15, I know gets me halfway to B. That's the midpoint. So that's going up by 14. I know I'm just going to repeat that. Going up another 14 takes me to the x-coordinate of B, which is 29. Same logic here, going from the y-coordinate to the midpoint. We know that gets us halfway. We're just going to repeat that pattern. That's going down 6. So we just go down 6 again, down to -10. From -4, going down 6 to -10. All right. Number 3, we're finding the midpoint between these 2 points. That is tough to read. That's at -2, 1, and 3, 5. So we're going to add our 2 x values together. That would give us a +1 divided by 2. And add our 2 y values together. That would give us 6 divided by 2. So we can simplify that. 1/2 is our x coordinate, and 3 is going to be our y coordinate. All right, if a circle has a diameter with endpoints of 1, 2, and 6, 14, what's the location of the center? The center is going to be the midpoint for any diameter. If you draw a diameter, the center has to be directly halfway in between. It's a radius plus another radius. So we're really just going to find the midpoint between those two. Add our x's together, divide by 2, add our y's together, and divide by 2. So we get 7/2, which we could just leave as a fraction. That's 7/2. And then 16/2 is 8. That's how you find midpoint.